Who am I? Scott Lowe. I work with the MC Corporation, as you can tell by the attire here. I am also responsible for the blog.scottlowe.org website. It's been a virtualization-focused website for the last 5, almost 6 years now, and has been consistently ranked among the top virtualization-oriented blogs on the internet. And I did write 2 books last year, the most well-known of which is Mastering VMware vSphere 4, which plug is available in the bookstore upstairs. All right, so with that in mind, let's go ahead and jump right into the content. Fellow team members who have been through a speaking class, no pointing out my speaking flaws. Okay. So a quick look at what we're going to talk about. We'll start with a quick review of EMC Virtual Storage as it's implemented in our vPlex product, which we announced back in May. We'll then move very quickly into the impact of using vPlex in your vSphere designs. So you are going ready to design a VMware vSphere environment, and you are interested in incorporating vPlex into that design. What are some of the design considerations that you need to keep in mind? After that, we will move into an operational discussion. What are some of the impacts that vPlex has on operational concerns, or operational procedures, processes, that sort of thing. I'll then throw up some additional information for you along the way, and we'll wrap up with Q&A. Now, I'll have a Q&A section at the end, but you're welcome to ask questions anywhere along the way, okay? All right, so first, a quick review of what vPlex is and what it does. vPlex is an inline storage federation and virtualization solution that provides data mobility. That's a great marketing term that says basically it takes your existing storage and virtualizes it and does lots of cool things with it, okay? It is a fiber channel only solution today, but there is Ethernet connectivity on the roadmap. It is an active scale-out architecture. What that means is that as you add engines and you add directors to a vPlex cluster, or as you add clusters to a Metroplex, storage is active on all ports at all times. So we're talking about the ability to add scale very, very easily, start out small and grow large, okay? And when I say large, we're talking a vPlex Metro configuration can have up to 8 engines, 16 clusters, and manage a total of, today, the highest they've actually tested is 16,000 LUNs. Okay, that's a testing configuration, not an actual, this is all we can handle. One of the great things it does is offer distributed cache coherency. That means that as you stretch this configuration into a Metro configuration, the cache is consistent across both sites, okay? Which is an important piece for a lot of reasons, which we'll discuss as we get in here. And there are 2 versions, local and Metro, that are available today. A quick look at the roadmap. Local and Metro I mentioned were GA'd back in April, announced in May at our EMC World Conference. On the roadmap is vPlex Geo, which if you got a chance to go to Chad Sakich and Pat Gelsinger's super session yesterday, you saw a demo of vPlex Geo offering long-distance vMotion of VMs from Boston to Omaha, Nebraska. All right, which is pretty cool. Why Omaha? I don't know. I guess it was a good point in the middle of the country. So that's on the roadmap, due to be delivered next year. Farther out on the roadmap is our vPlex Global, which stretches out to not only asynchronous distances, but multi-site configurations. So right now, vPlex Metro is a 2-site configuration. vPlex Geo will be a 2-site configuration. vPlex Global will go to point to multi-point kind of topologies, multiple hops, all that wonderful jazz. Quick look at some terminology. Okay, just so that we are all on the same base when I start talking about Metro distributed virtual volumes and extents and that sort of thing, clusters and preferred sites and non-preferred sites. I don't want you guys to get lost in the terminology. Okay, we use the terms storage volume, extent, and device to refer to pieces from the back-end storage. That back-end storage could be EMC storage, it could be non-EMC storage. Okay, it can be dissimilar, heterogeneous, meaning in both vPlex Local as vPlex Metro configurations. You could have an array of one type as well as an array of another type, both being federated through vPlex. You build these devices up. You take storage volumes and extents and devices and potentially concatenate them if you're so desired. You present these out to your host as a virtual volume. A virtual volume can then be stretched across a cluster to become a distributed virtual volume and help us to avoid confusion around Geo versus Metro. We try to refer to this as a Metro distributed virtual volume, which is a real mouthful. And I've told the marketing folks they really need to find a cool acronym for that, maybe the MDV squared or something like that, you know? And we distinguish that as you move into vPlex Geo, and you talk about these asynchronous distances, then we're going to start talking about geo-distributed virtual volumes. An engine is one of the basic building blocks. Every engine has two directors. The directors are fully redundant. We'll see a picture of that in just a moment. You build multiple engines together into a cluster, and you take two clusters together and you put them in, and they are a metroplex. Okay? So, terminology down. One more thing I'm going to cover that is specific to vPlex, and then we'll move into the design considerations. One of the key things that vPlex does in its metro configuration, okay, is it allows you to take a virtual volume and stretch that virtual volume across two clusters in a metroplex to create a metro distributed virtual volume. Now, what that metro distributed virtual volume actually is, it is a read-write, fully active volume that can be accessed simultaneously on both sides. This means you could have hosts in site A. I got to go double-handed here, okay? So you could have hosts in site A that are read-write access to this distributed virtual volume, as well as hosts in site B that also, at the same time, have read-write access to that distributed virtual volume, okay? vPlex handles the problem of simultaneous block access and all that kind of stuff. What vPlex doesn't handle is file system issues, okay? In the VMware context, this is not an issue because we know that VMFS is a clustered file system. We're automatically able to join multiple hosts together when we put VMFS onto a LUN and then put them on there. That's fine. Other file systems may not necessarily be clustered file systems. NTFS, for example, is not a clustered file system. So you couldn't take a Windows 2008 host on one side and a Windows 2008 host on the other side and join them to the same LUN. Why? A file system issue. Not a vPlex issue, a file system issue. So keep that in mind, okay? But it gives you read-write access. Now, you might think, well, I'm reading and writing to this distributed virtual volume at the same time from two different sites. What happens if there's a cluster partition? What happens then if that link in between the cluster, which is comprised of both IP links and fiber channel links, okay, for two different purposes, and if you want to know more detail, see me afterwards. What happens if that goes down, okay? Well, as you'll see the side build, what actually happens is one of these two sites has its I/O suspended to avoid a split brain scenario. And this is true with any stretched cluster configuration, okay? Any sort of storage configuration, as far as I am aware, you take it and you do something like this and you have a cluster partition, you're going to have to do something to avoid split brain. If you don't avoid split brain, then you run into data corruption, data loss, et cetera, and that's just bad, and we don't want that to happen. In the case of vPlex Metro, when you take a distributed virtual volume, a Metro distributed virtual volume, and a cluster partition occurs, one of these two sites will go I/O suspended. Not read-only, but I/O suspended. The virtual machines, if they're running in that case, they will go through their guest OS timeout values, and when the guest OS timeout values expire, then they'll crash. They'll blue screen or, whatever, kernel panic, whatever. How do we determine which of these two sites goes I/O suspended, and how do we determine which one remains read-write? That is done through a set of rules. These rules are defined on a per volume basis. I have one distributed virtual volume displayed here. For that one distributed virtual volume, I have the ability to define that site A would be the preferred site, and site B would be the non-preferred site. In the event of either a cluster partition or an entire cluster failure, and the only time this happens is in those two failure scenarios, okay? And those two failure scenarios are going to be really the little bitty part, the 10 out of the 90 and 10, okay? If even that much. That's when this would kick in. The preferred site remains read-write. Everything's cool. No changes on the preferred site. Everything keeps going. Everything keeps running. Everything's happy. Okay? On the non-preferred site, I/O is suspended. And these rules that you define, they're defined on a per distributed virtual volume basis. So if you have 5 distributed virtual volumes between your two sites, each of those distributed virtual volumes could have a different set of rules defining which site is primary and which site is preferred and which site is non-preferred. All right? Does that make sense to everybody so far? All right. And you can change these on the fly. All right, it's all configured in the management GUI. All right, so with that in mind, a quick review, storage failure scenarios, okay? Remember, the only time that this idea of preferred site, non-preferred site comes up is when you have an entire cluster failure. If you have multiple engines in a cluster, you could lose an entire engine. Remember, all ports are active. This is a fully active scale-out kind of architecture here. You could lose an individual director. You could lose an entire engine. If you have multiple engines, you could lose multiple engines. As long as at least one engine is still accessible or one director is still accessible, you still have connectivity. All right? The only time we talk about preferred site, non-preferred site is when you have an entire cluster failure or when you have a cluster partition. All right. With that in mind, let's move into a discussion then of what kind of impact does this functionality being offered by vPlex, what kind of impact does it have in our vSphere designs? We're getting ready to maybe incorporate vPlex into an existing environment, or we want to start out in a new environment and we want to include vPlex in that new environment. What are the things we need to keep in mind when doing that? Design considerations. Okay, I was just chatting with a fellow coworker who went through the VCDX panels recently, and if you're along that path or headed along that path, you know it's all about impact, all about knowing the impact of your choices, right? So what we want to talk about is what is the impact of incorporating vPlex into your design. You got to know what pieces it's going to touch, and this at least will get us started down that path. All right? So here are some of the things we're going to talk about real quick in terms of how we incorporate this sort of functionality into a vSphere design. First, in order to ensure the maximum level of availability. Okay, vPlex is a high availability solution. It's not a DR solution. We'll talk more about that in a moment. Okay, but it's a high availability solution. So in order for you to ensure that vPlex has the highest possible levels of availability, you're going to zone your ESX hosts. Okay, so that they will be accessing multiple directors inside multiple engines if you have multiple engines. If it's a single engine configuration, you would zone your hosts so that Fabric A went to one director and Fabric B went to another director. Pretty standard stuff. If it's multiple engines, you're going to zone it so Fabric A goes to a director in an engine on Fabric A, and the other path goes to Fabric B in another engine on another director. Okay, and I have an example of that in a moment. You can see here's a diagram, kind of one of the recommended ways you might zone or set up your engine. In this particular case, we've taken director A, which is the lower director, and director B, which is the top director. You have front-end ports, which are your targets for initiators, your ESX, ESXi hosts, and you have back-end ports, which are themselves initiators that go to your back-end storage array, and the target ports on your back-end storage array. And they can recommend that you zone half of them, like evens on Fabric A, odds on Fabric B, some sort of scenario like that. The magic of even odd doesn't really matter. You're welcome to flip them if you want. Just use something consistent. Okay? This ensures that hosts, as they go through the fabric, can be able to reach any engine, any director, or some combination of those so that if there's an engine failure, if there's a director failure, they will still be up. Remember, the only time you suffer an outage is if you lose an entire cluster, or in the event of a Metroplex, you lose the entire Metroplex. Key piece here that you want to keep in mind is you don't want to zone or present your LUNs both from the vPlex and from your back-end storage array to your end hosts at the same time. Okay. As you encapsulate data into the vPlex, you want to make sure that it's not being presented back out through another path that's not being managed by vPlex. Doing so can result in data corruption. And last time I checked, none of us wanted data corruption. Anybody here for data corruption? Didn't think so. Okay. So that's a key part to keep in mind. A little bit later in the presentation, assuming I have time, because there's a lot of material here, we'll talk a little bit about the migration process. Here's an example of what it would look like in a multi-engine configuration. You see Fabric A goes to a port in one engine, one director. Fabric B goes to another port on another director, another engine. Okay, and this is, again, this ensures fabric failure, port failure, engine failure, director failure doesn't affect it. There's a question right here. You will, so from a zoning perspective, you're going to zone the question was, he wasn't quite clear on the zoning piece, and I apologize, I didn't explain it clear enough. You're going to want to change your SAN zoning so that your ESXi hosts don't see the targets on the back-end array, so that they see the targets on the vPlex. And then you'll zone it so the vPlex sees the targets on the back-end array. It's an inline device. Okay, does that answer your question? Great. So an example of multi-engine dual fabric configuration. As with any sort of enterprise class configuration, we absolutely recommend that you use multiple fabrics, and that's a pretty given kind of scenario there. All right. Now, talking about zoning and connecting naturally brings us to a discussion of multipathing. If I have a host and it has multiple connections, What am I going to do about multipathing? Because I'm going to see that LUN and I need to be able to manage those paths. We can work with NMP, the native multipathing plugin. Remember I mentioned earlier that vPlex is an active configuration. Now what this means is that normally it's going to use the active SAT-P storage array type plugin, and either the fixed or round-robin multipathing policies would be appropriate, either one. Now, because vPlex does some caching and does some cache consistency algorithms, we generally recommend the fixed multipathing policy. This ensures maximum efficiency for the caching algorithms that vPlex provides. And then you would perform static load balancing across those paths, but just by setting your preferred path. Yes, question?
If you're talking about caching, read cache, write cache, both of that?
So the question was, what type of caching are we talking about? Primarily read caching. The cache on vPlex is today a write-through cache, meaning that we don't buffer the writes in the front end. We just commit them directly to the back end. Now, it is true that in a large environment, you could run into some manageability issues, manually setting the preferred path to do static load balancing across all your hosts. You can resolve that issue by using PowerPath VE, which is fully supported with vPlex. The default setting of adaptive will work fine for the vast majority of workloads. For some workloads, you might see a benefit from Stream IO, and some of these workloads are documented in some of the vPlex documentation that I'll refer you to in a moment. You can set the default value for PowerPath VE. There's a class that vPlex identifies itself as, and you see that says it's in Vista, and I'll talk more about that in a moment. You can set that default class so that anytime it picks up a vPlex volume, it automatically sets the policy, okay? But in the future, future versions of PowerPath VE are going to adjust that automatically as they detect the devices in the back end, okay? Now, I mentioned Invista. vPlex is not based on Invista technology. Okay, it does identify itself as an Invista device. We needed some way when hosts and initiators make a query to identify itself in some fashion using a SCSI identifier, that sort of thing. We use the Invista name just as a way of identifying itself. This technology is not based on Invista. Invista is a separate type of technology, okay? So don't get the two confused. They made the unfortunate choice of using that identifier, but it is a different kind of technology. This is the rpowermt command that you would use to set the default class or the default policy on a host for that class of device. Obviously, if you do have Invista in your environment, Invista being our out-of-band storage virtualization solution, you wouldn't want to set this as a default for the entire class because that would affect both vPlex and Invista. In that case, you would set it on a per-device basis. All right. So I'm going to come back now to a discussion of behaviors with the preferred site, non-preferred site, and why that's important. Remember that when we're talking about a vPlex metro configuration and we run into an issue where there is a cluster failure or a cluster partition, in this particular example, I have a cluster failure at the preferred site. Remember that this would mean all the engines at that site have failed. In a multi-engine configuration, the loss of a single engine does not mean an outage. Loss of a single director does not mean an outage. Okay, you need all the engines to fail. And so the likelihood of this occurring is fairly minimal. In that particular case, we know that preferred site, non-preferred site, the preferred site is going to remain read-write, the non-preferred site is going to have its I/O suspended. Well, in this particular case, it's the preferred site that has failed, and now we have the non-preferred site running. What happens in that kind of scenario, okay? Well, in this kind of scenario, the preferred site has failed, so all the VMs that were running in the preferred site are now, they've crashed because the preferred site has failed. And the VMs on the non-preferred site, their I/O is suspended because the non-preferred site suspends I/O upon a cluster failure or a cluster partition. You can manually go in and resume the I/O. The administrator can do that. We didn't make that an automatic fashion because, again, we don't know whether cluster partition or cluster failure. We don't know the difference yet. We have no way of doing that. This behavior, by the way, will go away in the future when we add third site witness capability to vPlex Metro. And then the third site will be able to say, oh, this is a cluster partition or this is a site failure, and then they'll be able to automatically remediate that behavior. Okay? But right now we only have two sites. We can't tell what's going on here, whether it's a cluster partition, preferred site failure. In this case, the administrator can manually go in and resume that I/O at the non-preferred site. But the real point we're getting at here is that regardless of what site fails or whether it's a cluster partition, if you have some VMs that are running in the preferred site and you have some VMs that are running in the non-preferred site on the same stretch metro distributed virtual volume, okay? Then in the event of a cluster partition or site failure, those VMs are going to be affected. Okay, if the preferred site fails, there's going to be affected there. That's of course expected. If the non-preferred site fails, well, VMs that were running there will be affected, but obviously the other site won't. But in a cluster partition, what's going to happen? All right, you want to make sure that you are aware of where your VMs are. So be sure and place the VMs in your preferred site or non-preferred site, and try and keep your related VMs together. Okay. If you have a multi-tier type application where you've got some front-end web servers and some back-end servers or something of that nature, and some are here and some are here, and then you have a cluster partition or a cluster failure, some portion of those VMs are going to be affected, and you may not know which if you're not keeping track of VM placement. So how many in here have done something like a plan and design type activity for Site Recovery Manager? So one of the things we talk about in Site Recovery Managers, you place your related VMs together that have a similar failover requirement in a protected group, and that way you can fail them over as a unit. All right, you wouldn't necessarily take one VM that had different SLA and put it in the same protection group, because then it would fail over in that protection group as well. Similar kind of scenario here, in that you want to keep your related VMs together, because on a per volume basis you control which site is preferred and non-preferred, and therefore, if you have a group of VMs that need to be up and they're stretched across both sites, one of those two sites is going to be affected, and not all the VMs are going to survive. Okay, so it's just a matter of just recognizing the impact of the design. When you do this, just be aware of what's going on. Know that, keep in mind this preferred site, non-preferred site behavior, and plan accordingly. Okay, if you need to account for that behavior, there's a couple ways you can do that. One, you can use storage vMotion to move between distributed virtual volumes. Okay, this is just a LUN. It's just a data store, so it behaves just like any other with respect to storage vMotion. So you could always do a long distance vMotion. We'll talk more about that in a moment. You could do a long distance vMotion over to the other site, and then storage vMotion it across to another data store who was defined as preferred for that site. You can also, as I mentioned earlier, change the rules. How do you like that? We can change the rules. Okay. You can modify the detach rules, is what we call them, the preferred, non-preferred site rules for that volume, to say, I've moved a bunch of VMs over here, now I want that to be the preferred site. So that in the event of a cluster partition or a failure, they will continue running. Does that make sense? Not to the other site, between distributed virtual volumes. There's only one picture here. Yeah, but you might have 3 or 4 or 5 distributed virtual volumes, and you would just be kind of a lateral move within a site, if that makes sense. The question was, why would you need to do a storage vMotion? We're not talking about storage vMotion this way, but rather this way across multiple distributed virtual volumes in the same site. Question? What distance? Right now, that's a great question. So the question was, what distance are we supporting here? Right now, the distance is about 100 kilometers, less than 5 milliseconds of latency. Okay? That's for the vPlex Metro product. Remember that Geo is already on the roadmap and has already been demoed, and that will be much farther. Okay? Does that answer your question? Yes. Okay, good. Other questions before I proceed? Yes, in the back?
Even though the distance will increase, will the latency tolerance increase too?
Yes, latency tolerance will. Question was, even though distance is increasing, will the latency tolerance also increase? Yes, latency tolerance will also increase, absolutely. Okay? All right. If you have critical VMs that you want to ensure that you can control preferred, non-preferred site behavior anytime you need to move it, you can use a dedicated stretched volume. Okay, much in the same way you might say, if I wanted to have a per VM granularity in SRM, you could say I'm going to put a VM on a data store and define a protection group for that data store, then I have per VM granularity. Okay, it doesn't scale real well for a lot of VMs, but if you have certain VMs or groups of VMs, you place them together based on that, and then you can move them en masse and define the rules based on that level of granularity. Now, that third bullet there, size stretched data stores based on I/O requirements. This is a synchronous type solution. We are synchronizing data between the two sites. Okay, you want to be sure and keep this separate from like a recover point type area where you might have asynchronous replication. This is synchronous replication, a synchronous mirroring of data between two locations. For that reason, the more VMs you put in a stretched volume, the more I/O you're going to put across that FC link. So just size your data stores and place VMs in your data stores with an anticipation or understanding of what their I/O requirements are, and then plan accordingly based on your connection between those two sites. All right. Now that brings us to a discussion of stretched clusters. Okay. Good friend Duncan Epping brought a lot of attention to this recently with an article that he wrote on his site about using a stretched solution and doing clusters and using an unsupported HA configuration to help with that. So before anybody corrects me on that bullet down there, no way to control primary, secondary node selection. It is an unsupported configuration. Anybody read that? No? A few? Okay, all right. We'll talk more about that in a moment. But when we talk about what we can do here with a metro type configuration, now we have the ability with read-write storage in two locations to actually stretch our cluster across two locations. Okay? This is a supported configuration. Okay, it is a supported configuration. We have a KB article that we wrote in conjunction with VMware. I'll point that out to you in just a moment and have you write down the number so you can refer to it later on. Gives you all the details. All right. However, you want to be sure that you're aware. Remember, always talking about the impact. Okay, and make sure you're aware of what effect that will have and the things to keep in mind when you do that. All right. A couple things to keep in mind. First of all, as you stretch an HA-DRS cluster across two sites, you lose the ability to control your VM movement. So when we're talking about knowing VM placement with regard to preferred site, non-preferred site, okay, now you've lost that visibility. All right? I'm going to talk about 4.1 in a moment. Bear with me. Okay. So again, we talk about if DRS is moving VMs around and then it inadvertently moves a VM off to the non-preferred site and you don't know it, then how are you going to handle that, okay? It doesn't control HA failover. And again, there's no way to control primary, secondary node selection. So as you're probably aware, VMware HA in its current iteration has a mechanism whereby the first 5 nodes are primary nodes. Everything after that is secondary nodes. If you lose the first 5 nodes, okay, which are the primaries, if you lose all your primary nodes, HA doesn't work. There is no automatic restart of VMs. And in that case, if you were going to stretch your cluster across the sites, you would want to make sure that some of your primaries were in site A and some of your primaries were in site B. All right? So there you go. Right now, there's no supported way to do that. In addition, think about admission control. How many of you guys use HA admission control? Okay, fair number. Admission control, again, is that ability to say, I'm running a cluster and I've configured my cluster for a certain amount of capacity to handle failure. Maybe I've just figured it for failure of 2 nodes or 1 node or whatever the case may be. And based on calculations on slot size, and if you want to know about that, Duncan's the man to talk to because he went way, way deeper than that with anybody else ever wanted to probably. It's going to come to a point where it's going to say, you don't have enough capacity to start up another VM. Okay? Because it said, you wanted to enforce to make sure that if I had a failure, there was enough capacity to restart what you've got running. I'm going to enforce that. You can't start up another VM. The HA admission control algorithm isn't designed to lose half of the cluster. If you really wanted to guarantee that you could lose an entire site and still bring all your VMs back up, you'd only be able to run your stretched cluster at 50% utilization. All right? The admission control just isn't designed for that type of environment. It's designed for losing 1 server, 2 servers, something of that nature. Now, with the release of 4.1, some of these points change. Okay? 4.1 introduced host affinity rules, DRS host affinity rules. There are hard, i.e. required rules. This VM must run, must not run. Okay? And there are recommended rules, should run, should not run. Okay? And these rules allow us, along with the definition of VM groups and host groups, to say I'm going to define a group of hosts, and I can say that this group of VMs must run on this group of hosts. All right, I can say that this group of VMs must not run on a group of hosts, something of that nature. And you might look at that and say, all right, Scott, that fixes the problem. I can use a hard required DRS rule, and I can say that I can create a VM group and say, here's all my Site A VMs, here's all my Site B VMs, here's a host group, here's all my Site A hosts, here's all my Site B hosts. Site A VMs must run on Site A hosts. Site B VMs must run on Site B hosts. There you go. Done, right? It's all settled. Right? Anybody out there? Okay. Well, it's almost kind of settled. It does control VM movement via DRS. It does control placement via DRS. It does control HA failover to a certain extent, although if the entire site goes down, HA will violate those rules to bring the VMs up on the other site. Even though you said Site A VMs must run on Site A, if it loses all the Site A hosts, it will bring them up in Site B. But it doesn't address the primary, secondary node selection, okay? And it doesn't address the behavior of the admission control, all right? Now remember that there's been discussion about this non-supported setting, des.preferred primaries, that you can set and will control which ones are primaries. It is an unsupported setting, and I would ask you, do you really want to base your enterprise on an unsupported setting in the event of a significant failure? Okay? So while you can it is a fully supported configuration, both by VMware and by EMC, we want you to go into this knowing what the potential caveats are of a stretched HADRS configuration. Yes, it's doable. Yes, many of you will do it. Just be aware of what the considerations. Be aware of the impact of that decision. Okay? So, what are our recommendations? Here are our recommendations. HADRS stretch clusters supported. Keep that in mind. We recommend using separate HADRS clusters in each data center if you can. All right? This ensures that there are no issues there. Use separate distributed data stores for each cluster. So you'll have a group of data stores in Site A that are associated with Cluster A. You have a group of data stores that are associated with Site B and Cluster B, and your preferred, non-preferred site rules basically create an affinity. These group of data stores associated with Cluster A have Site A defined as their preferred site and run with Cluster A. These group of data stores have a preferred site rule for Site B and are associated with Cluster B with host in Site B. And this ensures that the behavior behaves in a way that you expect. Use vMotion to move VMs between sites as needed, okay, between clusters. Remember, a cluster is not a vMotion boundary. Okay, a lot of people seem to forget that a cluster is not a vMotion boundary. I can easily do a vMotion between two clusters, not an issue. Okay? We do recommend that you try and keep your related VMs together. This goes back to the preferred, non-preferred site behavior. Okay? If you have VMs that perform, all participate in the function, and you don't want to lose some of them due to some sort of failure, you want to try and keep them together. Okay? If you do need to move a group of VMs, you can always change your preferred, non-preferred site rules. Okay, remember, those can be changed on the fly. So you have a group of VMs, you move them from Site A, you do a long-distance vMotion over to Site B in that cluster, then you can always change that rule to then make that site the preferred site for that particular volume. This is the KB article I recommended that you write down, okay, 102.6692. It was recently written, Chad Sakach, myself, some of the vPlex product engineers, along with some of the VMware HA engineers at VMware, all contributed to this article. Have a look at that. It gives you the full breakdown of HA behavior when used in conjunction with vPlex Metro. And it will be updated once vPlex Geo becomes available. All right, anybody need a moment longer to write that down? Okay. All right, moving right along. How are we doing on time? All right, I'll try and hurry up because I know you all want to go get in line for your next session. vMotion over distance, again, fully supported here with vSphere and vPlex. We feel vPlex is a key component of making long-distance vMotion or vMotion over distance possible. Having vPlex there and having active storage there, however, does not eliminate the other requirements that are necessary for vMotion over distance. Yes, it's very important, it's very critical. We are very excited to have delivered it to market. But you still need minimum bandwidth as specified by VMware. You still need maximum latency. You still need the equivalent of stretched IP subnets or stretched VLANs so that VM connectivity is not affected when you vMotion a VM from Site A to Site B. Okay? You can leverage a variety of technologies to do that. Cisco OTV would be one. There are others, and if you want to talk about them, I'm sure that any of the Cisco folks attending the conference would be happy to speak with you about them. Chad had a session, 8051. They actually changed the number. It was TA8051, not PC. His last session was this morning, so I can't tell you to go see that. But after the conference is over, pull that up for more detail, specifically around the long-distance vMotion use case and the idea of VM teleportation. I'll be mentioning that just very, very briefly. But his presentation, anybody get a chance to see that? Okay, all right. I heard it was very, very good. Generally, anything Chad presents is awesome. But be sure and look that up after the conference is over. Okay, TA8051. For more information on the long-distance vMotion use case specifically. All right. This is not as much a design consideration, but it wasn't really an operational consideration either, so I just kind of threw it in here. But I've had people talk to me about FT, and they're saying, FT is great because I can use it to protect a VM, and I can protect against host failures, and yes, we know about the single processor limit, and VMware's working on that. Okay, great. But what it doesn't do is it doesn't address back-end failure. What if my back-end SAN fails? FT isn't going to help that. It doesn't mirror the writes to two different data stores. I mean, they both reside on that same back-end data store. Well, what I wanted to point out here is you could actually use vPlex to provide SAN redundancy in conjunction with VMware FT. And this was true for both the vPlex local product as well as vPlex Metro. Now remember, we can stretch clusters, so you could conceivably run FT across a stretched cluster if you had sufficient bandwidth, okay? But what we do here is that vPlex itself doesn't offer any single points of failure. Every engine is redundant, every cluster is redundant, all ports are active, blah, 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 yada, 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 okay? What you can do is you can actually create a virtual volume that spans 2 different back-end arrays. Those back-end arrays may be in the same data center, they may be in 2 different data centers, they may be right next to each other, maybe up to 100 kilometers apart, but you're actually going to mirror data between both back-end storage. If one of those back-end storage arrays fails, the distributed virtual volume remains online. There's no interruption of service, okay? In fact, I believe Chad pointed out in his session that one of the supported configurations actually has vPlex at one site with no back-end storage, mirroring with vPlex with another site with back-end storage. That's a supported configuration that's documented in our setup guides. So that's something that you could think about. If you have a customer whose VM workloads fit VMware FT, okay, and you want to provide the highest levels of redundancy available, you could leverage vPlex to provide back-end SAN redundancy, along with FT providing the front-end host redundancy that you need. No configuration required on the VMware side, by the way, because when we stretch volumes across back-end storage arrays like that, it's completely transparent, okay? I really want to hammer down to you guys that when we stretch this volume between there, it is the same volume, same SCSI identifier, same LUN ID, everything. It's the same volume, okay? No resignaturing required or anything like that in the different sites. Sir? How is it working? Which one? Mirroring between the sites. That's handled by vPlex. So it uses its own synchronization and mirroring mechanism to mirror the data between your arrays, both within a data center or across the synchronous distance in multiple data centers. It's there. Catch me afterwards, there's a document that I'll refer you to as well. And if you're an EMC customer or EMC partner and you have PowerLink access, check the vPlex product family area. All the documentation there lays it out and it'll tell you exactly how you need to cable everything up. Okay? So the question was, is vPlex using mirror view? No, vPlex actually doesn't use any of the existing replication technologies that EMC has in place. And remember, vPlex is not a replication piece. It is a mirroring technology. Okay? So it doesn't leverage recover point, doesn't leverage mirror view, doesn't use SRDF. Okay. Further questions? Yes, sir.
You have sort of a reference architecture, or maybe working on one, where you show here's how vPlex would be used in combination to enhance SRM with recovery point. Since some workloads you think, here's to characterize, here's which workload you prioritize this way and how you complement that with vPlex. Because some of the protections you can see, at first blush, are quite similar.
So I'll boil the question down to say, are we working on some sort of white paper reference architecture that shows how we can integrate vPlex with SRM? Is that a reasonable kind of?
Yes, or
alongside of SRM, along with SRM, something like that. Okay, now we position vPlex as an HA technology to give you active data centers, okay? In a DR event, you could use vPlex. If all your data is being mirrored with vPlex, you could conceivably move all your data over. It wouldn't be automated yet. What we are working on, what's already been committed to, is an SRA for vPlex that would allow vPlex to be managed by SRM. In conjunction with that, you could use vPlex for some portions of your data and recover point, SRDF, mirror view, something like that, to manage other points of your data that maybe have a different SLA or are being replicated to a different location. I'm not immediately aware of any reference architectures to that effect, but that doesn't mean they haven't been written. I would just check the vPlex product area on PowerLink and see if anything turns up. And if you want to catch me afterwards and give me your card, I'll see if I can find anything for you. Okay. Yes, question back here. Well, so the question is, how different is it from mirror view? It isn't the same technology as mirror view. Okay, it's a different mirroring technology. It doesn't use the same engines or mechanisms that mirror view would use. It doesn't use the same mechanisms that recover point uses. It doesn't use the same mechanisms that SRDF uses in the symmetrics family. The mirroring and data synchronization methods that vPlex uses are specific to vPlex. For that reason, there really aren't any comparisons. Now, like I said, we have EMC has committed to an SRA for vPlex. meaning that just like you could have an SRA that plugs into Mirror View and an SRA that plugs into Solera Replicator and an SRA that plugs into Recover Point and an SRA that plugs into SRDF, there'll be an SRA that plugs into vPlex. Okay? All right. Any further questions? Great questions, by the way. Any further questions before I move on? Sure. So the question was, are there any performance measurements? And a comment made that it's another layer of abstraction. It is. Layers of abstraction give us flexibility, just like the hypervisor itself is a layer of abstraction. Okay. I don't have any specific performance numbers to give you. I would say when you're looking at profiling this, you would profile this in the same way you would profile a synchronous replication solution. Pretty much every synchronous replication solution I'm aware of on the market will write through and wait to the other side to commit that write and then acknowledge the write to the host, and that's what vPlex does. That's not unique to vPlex. It's common to pretty much every solution out there that I'm aware of. So in terms of profiling that, just keep that latency in mind as you talk about that. There may be specific data on PowerLink. I would recommend that you go there. And again, if you want to catch me afterwards and give me your card, I'll try and follow up with you. Okay? Question?
Doesn't this version of vPlex have upgraded processors and
So the current generation of vPlex, it uses the same processing engine that's found in our VMAX arrays. Okay? So same building block engine. Doesn't run the same software. It doesn't do Ethernet. It's fiber channel. Okay? Now, Ethernet connectivity is on the roadmap, but today it's a fiber channel solution. Yes, sir.
I just want to comment on the question that the gentleman asked about what the
performance characteristics.
the penalty on the voice writing.
Okay.
In Chad's session, that on Bitcoin, Chad had a slide out
Uh-huh.
on the thing, and they did measure it, and it's a very, very tiny penalty for that voice writing. So if you can download his presentation, you see the slide and get it. It's 200 microseconds.
Okay. All right. Great. That's good information. So, based on Chad, the all-knowing Chad, we're looking at about 200 microseconds of additional latency introduced, which, what is that, right? What's 200 microseconds between friends? Thanks, guys. I appreciate that. All right. Great questions. Thank you for all your great questions. Let's move forward. VAI support. We talked about VAI support. For those who aren't familiar with VAI, it's the vStorage APIs for array integration. It's a very sexy acronym right there. The ability for us to offload certain storage operations from the hypervisor onto the storage platform. Today, we do not have VAI support in vPlex. It is a committed roadmap item. Okay? I think that Chad or somebody else at his level was probably beating the vPlex developers over the head. Why didn't you do that? But nevertheless, it's not available today. It is available on the roadmap, and they have committed to delivering it soon. Keep in mind, though, that for the most part, a lot of the VAI commands are localized to an array. Okay? For example, on the current generation of VAI, we couldn't use the fast copy off or fast or full copy offload to copy data between two different arrays. That would only be within the same array. And since vPlex, by its nature, generally works across arrays, whether they be in the same data center or in a metro configuration, the lack of VAI support may not be as significant as you look at it and say, oh, wow. Yeah. Because of the nature of vPlex and what it's doing, it may not be as significant as you might think. It is a committed roadmap item. I promised the vPlex people that I would tell you guys that. It is on the roadmap. It is going to be developed soon. I can't tell you when, though, because they know where I live. So, all right. Let's move into some operational considerations, and I'll try and get you guys out of here. So, real quick, I'm actually going to jump through after submitting my presentation. I realized it probably best to talk about the last bullet first. So let's just flip through here and do this one first. Operational considerations. You have an existing vSphere environment up and running. You want to add vPlex to it. What's involved? Okay? I would first point you to this last bullet. There's a white paper available on PowerLink titled Using VMware Virtualization Platforms with EMC vPlex Best Practices Planning. How's that for a mouthful? Okay? That is an excellent document. I highly recommend you read it. It gives you all the details on encapsulating data specific to vSphere. One of the great things about vPlex, at least in my opinion, is that we can take existing data and we can suck it into vPlex management. Now, data migration doesn't happen. The data always stays exactly where it is on the array. We don't have to take free space on the array and then move stuff onto that free space in order for it to be managed by vPlex. We just have to wrap vPlex management arms around the data in place where it is on the back-end array. And then once we've got vPlex management wrapped around that, then we can do stuff like we can stretch it over to the other site, we can shrink it down to this site, whatever the case may be. That process can happen with, again, no data disruption involved. It's completely non-disruptive in terms of your data. However, we have to do that on a per data store basis because we can't have some hosts accessing the data store on the back end and some hosts accessing the data stores on the front end through vPlex, because then, remember we talked about that. You can't do that. That's data corruption at the same time. Nobody wants data corruption. So what we have to do is we have to take and encapsulate the entire data store at a time. If you wanted to use storage vMotion, you could move VMs out of that data store using vMotion, encapsulate that data store, and then move them back in. And you could do this migration, this encapsulation, with no downtime whatsoever. Okay? The process looks like changing your zoning, changing your LUN presentation, so the back-end array points to the vPlex and not to the hosts. Pardon me. And then rescanning for data stores. Okay? And then it picks them up, and then off you go. And it really is that simple. Okay? If you want to avoid downtime, there is some interruption to that data store. We have to change the SAN zoning. Okay? So I can't have them zoned both ways simultaneously. So I have to take this zone out, put this zone in. And that means there's an outage right there real quick. All right? But other than that, if you use storage vMotion to move them off, we can do it with no downtime at all. And no data migration. In other words, you could do this, aside from the time it takes to do the storage vMotion, if you wanted to take an outage window, you could do it just in 15, 20 minutes. We don't have to wait hours and hours and hours for data to copy or move or anything like that. All right, so now let me go back and talk about. So speaking of storage vMotion, I had some questions from some of the field staff and partners in VMware. Well, now vPlex is stepping on storage vMotion. They're very complementary. Storage vMotion is a granular way to move VMs from one data store to another. I can't. You could use storage vMotion to do a mass migration. How many people have done that? Use storage vMotion to migrate, 100 or 200 or whatever VMs. Yeah, was it fun? Yeah, no, it's generally not. Okay, you end up getting somebody who's good with scripting, and maybe you are, and you write a script, and it does all of that for you, and then somebody has to babysit it, and all that kind of jazz, right? That sort of mass migration, that's what vPlex is for. You take your encapsulation, you take the data into the vPlex cluster through encapsulating the data, and then you let it migrate the data on the back end. You take an existing array. Let's say you're doing an array replacement. You got old array, it's going out the door. You got new array, it's coming in the door. How do you facilitate that? In the past, it was storage vMotion. Now what we do is we take the old array, we pull it into vPlex, we mirror it onto the new array. That happens transparently, no doubt. Once that initial pulling it into vPlex is done, everything else is non-disruptive. Everything else at that point on is non-disruptive. We mirror it onto the new array. We remove the mirror leg on the old array, pull the old array out, ship it out the door, you're done. Okay? End of story. All right? Question?
So when you do that, and you move the old array out the door, are you then switching vPlex, or then vPlex sitting with this one array?
Then vPlex is sitting with one array. Question was, when I pull that old array out, what happens? Have I broken vPlex? No, absolutely not, because what you're going to do is you're going to go in and you're going to tell vPlex, don't mirror the data onto this array anymore. You're going to do what we call removing a RAID leg. You're going to take one of the legs out from under it, and it's only going to write to that. And then you just disconnect it and go from there. I don't know which one of you guys was first. I'll take you, and then I'll come to you. Go ahead, sir. There are, yes, there's both EMC and non-EMC arrays are supported. There's a list available from the PowerLink website, maybe on the public EMC website that says this is what's supported, this is what's not supported, and then we're working with the team to qualify more and more arrays. So, but yeah, you could absolutely go heterogeneous, HTS, I believe, is on the list, HTS and IBM SVC, EMC and something else. Okay, no worries. Okay, your question, sir.
What's the difference between this and the IBM SVC besides the distributed volume?
Well, the ability to distribute it and read write is pretty significant. The other significant difference is I understand it. I'm not an expert on IBM SVC. The question was, what is the difference between vPlex and SVC? The other big difference is that, as I understand it, vPlex is scale out, and the back-end storage that we pull through is capable of being presented on all engines across the cluster simultaneously. Whereas I believe in the IBM SVC arrangement, and I'm not an expert, you have to selectively say it's going to be visible here or here or here. Okay? All right. If you want to talk more, catch me afterwards. All right. Yes, sir. Sure. The question was, do you need a separate engine or separate director for every type of storage that you're putting in front of? No. We can have multiple heterogeneous, as long as they are supported. Okay, as long as they are supported, absolutely. Okay, and that's not to say that others might not work. They just wouldn't necessarily be supported because we haven't gone through. EMC is very, very particular about the support and being very, very specific and making sure that we can support it under any circumstance. That's why the list is a little shorter than some people might like. For limitation for support in what regard? Yeah, I mean, if it's not on the supported list, then you're kind of flying by the seat of your pants. Okay, all right. Sure, go ahead. So have we tested an FCOE environment? We just announced, not too long ago, we just announced the FCOE UltraFlex modules for our products. UltraFlex modules being a way to non-disruptively add FCOE capacity to an array, okay? And vPlex uses the UltraFlex technologies in the back of it, okay? Aside from that, and I don't know where the support statement is on FCOE directly into vPlex at this point, but aside from that, running FCOE at the end host, coming up to an FCOE switch and then splitting it off and going to your traditional fiber channel fabric, that's a fully supported configuration. Okay? All right. Because of the relative newness of the FCOE UltraFlex modules themselves directly, I don't know that it's been qualified with vPlex yet. Okay, but stay tuned for PowerLink for that one. All right, I want to move on because I know we're running short on time and I don't want you guys to miss your next session, even though we have half an hour. Another potential use case for storage vMotion is the idea of VM teleportation. Which is we think is a little bit different than just standard long-distance vMotion. And the idea behind VM teleportation is using vMotion to hop on to a distributed virtual volume, a metro distributed virtual volume, having vPlex synchronize that data between the two locations, and then having it hop off the other end to stay onto a non-distributed volume. So it starts out on a non-distributed volume, it puts on the distributed and gets vMotion to cross, and then it hops off at the other end. And so and it starts out non-distributed and ends up non-distributed, but what we've done is we've used vPlex to speed up that whole process, okay? We have a plugin that is going to be built into our VSI plugin framework that will automate this vTeleport process to do all this for you, so you can schedule it and say, I want to move a bunch of VMs, and it will just take care of that whole process for you. Okay, that's another way storage vMotion and vPlex work together rather than necessarily being competitive. Question, sir? Will vSphere be able to administer vPlex? I haven't seen any stated directions yet whether we're going to build vPlex management into vSphere. Given the direction where we're headed, I would imagine that is yes, but I cannot say for definitively yes, it will. Today it is a different touch point. That is correct. Yes. Question here. It works at a data store level. It works on a whole volume, okay? But what we're talking about doing here is using a process to put a VM onto a volume, because it's then on that volume, vPlex would mirror it, and then moving it off the volume after the mirroring is complete. Storage DRS. You're talking about actually moving volumes in the back end. You'd want to be careful about how you use storage DRS with moving volumes directly onto or off of a distributed volume, because you want to know whether it's going to be available at the other site, okay? So, not all your volumes have to be distributed. You might have some volumes running through a vPlex metro that are on this site only and are not on both sites. So if you're using storage DRS to move stuff around between volumes, you could potentially move it off of a distributed volume, and then when you expect it to be available at the other site and it's not, that's a problem, okay? You just have to keep that in mind. And remember, storage DRS is still experimental at this point anyway, so even if it were to work great, it's all futures, buddy, okay? All right, let's see. Wrong way, sorry. There we go. All right, one more slide, and then I'll wrap up and let you guys get out of here. Thank you for your patience. Operational concerns over long-distance vMotion, okay? This first one's something to think about. We don't recommend moving individual VMs on a regular basis. Why? Remember preferred and non-preferred site behavior. If you take one VM and you move it over here, and you got 10 VMs over here and one VM over here, and then something happens, cluster partition, cluster failure, something like that, what's going to happen? If they're related, if they help perform the same function, some group of those are not going to happen. They're not going to stay up. They're not going to continue working. All right? So for that reason, we generally recommend moving related VMs together in groups. All right? And then when that group is moved, either change the rules for that volume or storage vMotion them off to a volume that is preferred site. That way you're always in the preferred site wherever the VM is running. All right? Remember, we can't define per VM preferred, non-preferred behaviors. We can only define per data store preferred, non-preferred behaviors, not per VM. Right? So keep running related VMs together and adjust your rules on the fly. The detached rules, those are the rules that determine which site will remain preferred, which site will remain non-preferred. Those can be changed on the fly in the vPlex management GUI. So if you need to change them while you're moving VMs around, that's completely okay. All right, and at this point, I'll open up for any additional questions, or if you're done, thank you for attending. I appreciate it. Yes, sir. Thank you. Thank you. Well, so the question is, doesn't preferred, non-preferred take away from DRS and all that kind of stuff? It's in this generation, it is a bit static because you have to go in and define those preferred rules. But remember, we're talking about, it's kind of like being nitpicky over the fact that we have to have stretch layer 2 VLANs for vMotion. A few years ago, we couldn't even move a running workload from one location to another. Before the introduction of vPlex, you couldn't have, as far as I'm aware, active read-write storage in 2 different locations at the same time. I'm not aware of any other product that does that for the same line. You might have 2 different lines being replicated like this, so that it's active on this site and active on this site. But we're talking about the same LUN, not 2 different LUNs going like this. The same LUN active in both sides at the same time. Okay. This is actually based on the yada acquisition. That's correct. So, it is right. Okay. So you can go ahead and cut me off here.